Okay, so now I want to use what I've shown you in the previous video to calculate the inverse of an n by n matrix. So we'll use in my example, I'm going to use the matrix 1, 2, 3, 2, 5, 3, 1, 0, 8. And let's say I want to calculate the inverse of that matrix. Well, what do I want to do here? I want to find some matrix X, right? That is 3 by 3, right? It's a 3 by 3 matrix I'm trying to find, so that when I multiply A by X, I get I. So let's assume that X is written in terms of its columns. So I have, well, maybe I can just write all the entries actually. X11, X1, that's X21. Let me try to change that. That 21, X31, X12, 13, 22, 23, 32, and 33. So multiplying A by this has to give me I. Okay, so the way I'm going to solve this is I'm going to say, oh, actually, this matrix multiplication can be done by doing A times the first column of X. That's going to give me the first column of the product of A with X. Then A times the second column gives me the second column of A times X, and A times the third column gives me the third column of AX, and that's equal to I again. Okay, and I'm going to match each of these columns. For example, the first column should be equal to 1, 0, 0. So A times X11, X21, X31, that has to be equal to 1, 0, 0. Okay, well, what is that? So recall A is 1, 2, 3, 2, 5, 3, 1, 0, 8. So this is going to be 1 times X11. So this is what I'm doing here. I'm multiplying A by well, the first row of A by this column here, X11, X21, X31. So I get the first row of A is 1, 2, 3. So I multiply that against every entry of this column vector. So 1 times X11 plus, what did we say? 2, 3. 2 times X21 plus 3 times X31. That has to be equal to 1. And then 1 times X21 plus, whoops, sorry, it's not 1. This is a 2 here. So now I'm using these numbers, 2, 5, 3. So 2, 5, X21 plus 5 times X21 plus, a very limited memory, X31 equals 0. And the last row is 108. So that's 1 times X21. What did I do? This is 1, 1 here. And 1, 1 here too. Plus 0 times X21 plus 8 times X31, that's equal to 0. So I've got this system to solve in order to figure out the first column of X. Okay, and I'm going to do the same for my second column. But you'll see that this part is not going to change so much. The only thing that's, what I mean by that is the coefficients are not going to change because it's still going to be the coefficients of A. Okay, I still have A there. The variables are changing, but no matter how you call the variables, right, whether I call them X11, X21, X31, or ABC, it's the same system. So when I'm equating this column with this one, I'm going to get maybe I can write you the first equation of that system, but it would be again 1 times, but this time instead of having X11, it would be X12 plus 2 times X21 plus 3 times X31 equals what? Equals 0. Okay, you know what? I'm going to write them all. So x 2 times x 1 2 plus 5 times x 2 1 not 2 1 2 2 plus 3 times x 3 2 equals what? Equals 1. And now I'm going to get 1 times x 1 2 plus 0 times x 2 2 plus 8 times x 3 2 equals 0. So that would be my second system. My point is that, okay, the variables have a different name, but they're, I mean, I could call them ABC here, and here I could call those ABC, and I would have two systems with the same coefficient matrix. The things that are, what is changing are the entries of the constants that I find on the right hand side. So I'd have another system, a third one, by equating the third columns of each matrices above. So overall, what I would be solving is a system where I have matrix A here, but I can solve all three systems at once by putting the constant part that I find in each of my system, but by putting all those together, I just get over here the identity matrix, and this is matrix I. So in order to solve or to find my my unknown matrix X, I need to solve these three systems. I'd perform, I'd perform Gauss-Jordan. If I do Gauss-Jordan, eventually, if my matrix is invertible, I'll get a matrix I here. If I don't get matrix I, by the way, I'm going to get some row of zeros, and therefore I'll have a row of zeros equal to something that's non-zero on the other side, and I won't have a solution. So every time your matrix is invertible, you can get a matrix, you can transform A, you can put it into reduced, when you put it in reduced Roechlen form, it will become matrix I. Or I could just have invoked the equivalence theorem that that you've seen in a previous video, right? Remember, when a matrix is invertible, I can always reduce it to the identity matrix. So this matrix A here, actually, you'll see that it's invertible. I can do Gauss-Jordan on it. I will get matrix I, and on the other side, I'll get some unknown matrix. So let's say that this matrix is A, B, C, D, E, F, G, H, I. From this matrix, I can recover my unknowns. Remember, what were my unknowns? For my first system, it's x1, x11, x21, x31. Well, those correspond to the entries in this column. So actually, this column I wrote ADG, but it's actually x11, x21, and x31. And similarly, the column here, B, E, H, are what the variables x12, x22, and x32 are. And this is x13, x23, x33. So in fact, what I have here in the end is my matrix X. So after doing Gauss-Jordan, you get the unknown matrix X. You get which is the inverse of my of the matrix A given above. So the X that I'm looking for, remember, it's actually A inverse. So it explains why to find the inverse, what do? You put your matrix A, next to it you put I, you perform Gauss-Jordan. If it doesn't work out, what I mean by that, if you want to get the identity matrix. If it doesn't work out, it's because your matrix is not invertible. Because when it's invertible, remember, you can reduce it to the identity matrix. If it doesn't work, you have a proof that you have a non-invertible matrix. And if it works, you get over there the inverse of A. So what I want you to do is look at example 4 on page 55. And they have calculated the inverse of the matrix A that I gave you above. So they're performing those steps here in order to calculate the inverse. So read that example, you'll see that they get the inverse. And maybe at the end, if you could check that what they're giving you for the inverse does work, so that when you multiply A by A inverse, you get I. And that's always something you can do on an exam.